Hi, my name is Brandon Graisley. I'm a high school math teacher, and my students in my grade 11 class recently had a test, and I'm just going to go through all of the solutions for it. It's all about simplifying rational expressions, and there are some options with how to simplify things at the very end about what we're looking for. So sometimes we'll leave things in a partially factored form because it's more useful. Anyway, let's go ahead here. What we're looking for in this polynomial expression is we want to find any terms which have a variable part in common. So those two terms, for example, both have x squared in common, and these two terms here have x in common, just a single power of x as opposed to x squared, and then we have these two constants that are hanging out also. So we have 5x squared minus 8x squared, that's negative 3x squared. For the x's here, we've got negative 3 and another negative 3, that's negative 6x, and we have 2 and 5 is plus 7. So that is the simplified version of that polynomial. Let's keep going. I'm not going to take a real long time with any of these. This is 15x squared minus 21x. So that's using the distributive property to multiply here and here. And then I'm going to continue with the distributive property. Two more terms. We'll get negative 26 and a positive 14x. Negative 2 times each of these terms. So 1, 2, 3, 4 terms in the end. We started with 1, 2, 3, 4 terms in brackets, each one multiplied. So we still have 4 terms. Now we look for any terms in common, just like we did in the last one there. So we still have, sorry, I said that wrong, any like terms. Negative 21 and 14 is going to be negative 7x, and then we have minus 26 still. Okay, here we're using the distributive property twice, or some people call this FOIL. Multiplying x by each of those terms, and then 2 by each of those terms. X times 3x is 3x squared. Then I have a minus x, plus 6x from the next term, and minus 2. So I have 3x squared. The two x's in the middle here combine to give me, let's see, minus 1 plus 6 is plus 5, x, and then minus 2. Okay, now this one, part D, we have a monomial out front times a binomial times another binomial. So very commonly people will try to multiply this negative 3x times all 4 of these terms in the brackets, and that is a mistake. So let's start by just multiplying it into the first one. You could also multiply the two binomials together and deal with the negative 3x afterwards. That doesn't matter, it's the same thing. So I'm going to start with negative 6x and then plus 9x squared. I'll leave that in the brackets to show that it's still being multiplied by this one. Now I'm going to perform the same kind of action as we did up above, binomial times a binomial. So I'm going to do the negative 6x times each term here. Oops, sorry. Negative 18x squared plus 12x. Now 9x times each term. That is plus 27x cubed this time, x squared times x. And then 9x squared times negative 2 is negative 18x squared again. So how did I do there? Is that looking good? Okay, looking all right so far. So we've got a 27x squared at the front here. Sorry, I said x squared, x cubed. That's the highest power term there. And then I've got a minus 36x squared plus 12x. And that looks like everything. Now you'll notice that we ended up with only terms with x in them, and that makes sense because we had a negative 3x at the beginning there. Okay, so that is the first page. Okay, so let's start the second page. Here we need to state the restrictions on the variables in each expression. We don't have to simplify the expression, and that's because all the denominators have been simplified enough for us to work with. So in this one, we have 1 over x times y. Remember, a restriction happens whenever a denominator could be 0. So what values for these variables would make a denominator 0? The restrictions are, well, that x can't be 0, and also y can't be 0. Those are the two things that would be sort of bad, that would make the bottom 0. 1 divided by 0 is a no-no, so those are the two ways that could happen. Some people will also write x comma y not equal to 0, and that's also fine. So that is those are the two restrictions on that expression. For this one here, x plus 3 can't be 0 and x minus 5 can't be 0. These are two things multiplied together. They are both factors. Neither one can be 0. So to solve this, you might sort of know how this works already, but we can't have this happening. This would be bad. So we can put a little not equals, and you can solve this in the same way. This would mean that x is not equal to -3. Similarly, x minus 5 can't be 0, so x can't be equal to 5. And those are the two restrictions that we have on this expression. Now here, 2 times x plus 3 divided by x plus 3. Now it is true that you could cancel x plus 3 out of the top and bottom, the numerator and denominator, to get a simpler expression, 2. However, I don't need you to do that in order to find the restrictions on this expression. The restriction here is that x can't be equal to -3. That would make the denominator 0. So yes, this is equivalent to the expression 2 with this restriction, but there's no need to actually do that canceling just to find the restriction. And most importantly though, once you cancel these out, you do have a restriction. This is not equivalent to 2. It's equivalent to 2 with the restriction. Okay, and in this one here, once again, you don't need to factor the top and try to do any canceling or anything. We will have two restrictions. X can't be equal to 1 from this one. Positive 1 would make that 0. And it also can't be equal to -3. That would make the second factor on the bottom 0. So 1 and -3 are the two restrictions here. Okay, question 3. We have two functions. We have to decide, are these two functions equivalent? So, one thing you can try to do is simplify one or the other. You can also subtract them. And if you think that they are not equivalent, you could also substitute something in to see if you can make them not match if you substitute the same value into each. But this one looks simpler. It's a polynomial. It's in its simplest form. This one is not really in its simplest form. So let me just try to simplify g of x. G of x is equal to, well, I can divide both terms in the top by -2. That will give me -7x squared and then plus 5x. And although the terms are written in the opposite order, those are the same. That is equal to f of x. So they are equivalent. You can also subtract the two expressions to see that they are equivalent. You'll get 0. And there are no restrictions on either of these, but if there had been, the restrictions would have to be the same. So here we have k of x and m of x. They look a little bit different, so let's compare to see if they really are the same function. They do already have two restrictions. The restrictions do match, so that's a good start. So once again, k of x is sort of done. M of x, though, has some possibilities there. Let's try to maybe factor that. So on the top here, I've got x squared plus 3x plus 2. That will factor as, let's see, x plus 1, x plus 2, I think. Let me double check that. Yeah, that looks good. And on the bottom, it looks to me like I've got x minus 1 and x minus 1. That does not simplify any further. I can't cancel anything here, for example. So I cannot cancel, for example, this and this, which would give me k of x. This is not equal to k of x. And so they are not equivalent. And so you just have to kind of get to the point where it's sort of obvious that they're not equivalent, that anybody with an understanding of how these sort of fractions or rational expressions work will recognize that they're not equivalent. If you needed to, you could now pick a value. For example, you could pick the value like 4, stick it in there into k and m and see if they come out to the same value. And it wouldn't take too long to find something where it's different. Okay, so these two now, p of x and q of x, they look kind of similar, and it's very tempting for people to just square each of these terms. However, and this was a mistake, sorry, I did correct this on the copy for the students. This is a difference of squares here. This is equal to x minus 4 times x plus 4. However, this is x minus 4 times x minus 4. This is clearly not equal to p of x. You could also expand this one and see that you have a linear term. X squared, it'll be minus 8x plus 16, which is not equal to q of x. And so they are not equivalent. Okay, that was page 2. Okay, time for the famous page 3, which has question 4 on it. And I didn't leave enough room for people to typically write on here, but I think I can probably squeeze in most of it since we're doing this on a video and nobody has to read this afterwards. So we're going to simplify each expression if we can, and then state any restrictions on the variables. So we want to move to the simplest form. And once again, it's okay to have some factored, for example, if you had a trinomial as a denominator, it's okay to factor that as part of your simplest form, since in general we are going to be using things in factored forms anyway. So let's start by recognizing that I can do some common factoring. So on the top there I can factor out 5, and I'll be left with x squared minus 3x plus 2. In the denominator I can actually factor out 20, that's pretty big. Be left with x minus 2. So there's like step 1. Now this 5 and 20 here, if that were just a fraction, if you just saw 5 over 20, you might recognize that that is 1 over 4. So we can actually do that. We'll cancel that in our next step. So I'm going to write down the factorization of the top here, and I'm just going to leave that 4 down at the bottom. So there's the 5 over 20, and there's the 4 that resulted. Now on the top we have, it looks like x minus 2 and x minus 1. That's the factorization of that trinomial. So canceling, I guess I should mark how I cancel here. So when I cancel, I'm going to do that canceling right there, and I'll be left with x minus 1 over 4 with the specific restriction that x is not equal to this value here, positive 2. So as soon as you do that canceling, that restriction has to be listed. And because I'm sort of writing horizontally here, I would really write it like right there. That's where it should go. Okay, so this one here, let's go on to part B. So that one's finished now. We can't simplify anymore. You could write it as 1/4 x minus 1/4. That's fine. Okay, so this one here, x minus 3 over 2x minus 3. There are 2 terms on the top, 2 terms on the bottom. There is nothing we can do to simplify at this point because we can't factor anything out of the top or the bottom. And the top itself is not divisible by the bottom directly. You know, each term would have to be divisible by the bottom for that to work out, or the whole thing as a single unit. Like x minus 3 over x minus 3, sure, that works. But x is not divisible by this stuff. So you can't do any canceling here at all. So we're finished. It is simplified. However, we need to state the one restriction, and that is that x is not equal to, well, let's see here. Maybe I'll write off to the side. 2x minus 3 can't be equal to 0. That means that 2x can't be equal to 3, and that x can't be equal to 3 halves, positive 3 halves. Okay, so that is the restriction on that expression. Okay, now we have this one here, which is a product of 2 rational expressions. They're an expression here, and they're multiplied. Before we do multiplication, we can go ahead and do any canceling of factors. So I can cancel this and this, and when I do, I'll be left with this expression with x can't be equal to negative 5. Can't be equal to negative 5 because of right there. That can't be negative 5. Now here, I get an additional restriction that x can't be negative 2. It's okay for x to be positive 2. The top can be 0. Just the bottom can't be 0. So these are the 2 restrictions here, and that is the simplified expression with its restrictions. Okay, part D. This one has a quotient. We're dividing by a rational expression. The very first thing we do is rewrite this as a product instead of as a quotient. So instead of dividing by this, we will multiply by its reciprocal. I'm going to save a little paper and also work on this first rational expression by taking out a 2, factoring out 2. I'll get 2x squared minus 3x minus 2 all over x plus 5. That's the first the first rational expression here, and then we will multiply by the reciprocal here. On the bottom, we're going to get the x minus 2 from there, and the top is going to be this expression, 3x squared minus 14x minus 5, sorry. Ooh, it's a funky 5. All right, so now we can factor this, and start looking for factors that are in common in the numerators and denominators. So I guess I'll work down here, try to do that. So 2 and then x plus 5 on the bottom. This top thing here is a complex trinomial, so you can use decomposition to try to solve that. These numbers are quite small, so I can probably just do this. I think I got that right. Let's see. Negative 4 plus 1 is negative 3. Yeah, that all looks good. Okay, so that's a factored trinomial now, so you'll need to do that on your own if that was too fast for you. And then the top one, similarly, got some primes here, so it's not too bad. 3x and x, and that should be 5 over here, so minus 5 plus 1. 3 plus 1, yep, that looks good. Okay, so far we have done no canceling at all, and so we have no restrictions to add, but we are going to start canceling now. So right here we have an x minus 2, and down here we have an x minus 2. That x minus 5, x plus 5, those do not cancel. So kind of go up here maybe now. This is equal to, let's see what we have left. So I'm going to cancel out this term, oops, and this term here. And when I do, I get that restriction. So I'm going to have 1, 2, 3 terms on the top. 1, 2, 3, 4 terms on the top. Okay, that's fine. So I've got 2 times 2x plus 1 times 3x plus 1 times x minus 5. And in the denominator, I've got x plus 5 only. And I'm just going to write, I'm going to write this little restriction right here, that x can't be equal to 2. That's from the canceling that we did earlier. So I think we're probably done there. I don't see anything else that we can cancel. 1, 2, 3 binomial factors on the top. None of them match this one. So that looks like that question is finished there as well. One more thing. We need to add in this final restriction right here, that x can't be equal to 2, but it also can't be equal to negative 5. So that's the final restriction. 2 restrictions on that one. You can actually see those restrictions. I'll just mention. You can see them right here. Negative 5, positive 2. Those restrictions are sort of obvious at this point. But because we canceled some stuff, we have to make sure we list them. Okay, this one here, E. We're probably going to need some more space for this, so I got another piece of paper here that I think I'll write on. Let me write the question right there. So for E, we have 2 different rational expression sort of terms. They're being added together. And so in order to add these, you need to have a common denominator, just like with all fractions. So I'm going to need to factor this one to see what the denominator is made up of, so I know how much work I have to do to make this one look like this one. So I'm just going to kind of continue with an equal sign here. 3 over x minus 1 plus, and I don't think I can factor the top, but I don't need to right now, so I'm going to wait on that. And on the bottom, I need to factor the denominator, so this will factor as 2 binomials. It's a simple trinomial. It looks like I've got 2 and a 1, and because the middle term is positive and the last term is negative, I'm going to have a positive 2 and a negative 1. Let me double check that. Yeah, that looks good. And now I notice, maybe I'll put brackets here to make it really clear, that's one of my factors already, x minus 1, those match. But this one here is not in common to both denominators. So in order to make this fraction have the same denominator as this fraction, I will need to multiply top and bottom by x plus 2. So this was the old fraction. And now I'll multiply the top and bottom by x plus 2. And now that fraction has the same denominator as this one. Because they have the same denominator, we can add them together. So adding on the top here, I'm going to get 3x plus 6. And then I have a plus x squared plus 3x minus 13. All of that is divided by x minus 1, x plus 2. Now it's a really, really good idea to leave this factored down here, because we might get to cancel in a second. Let's find out what happens. X squared on the top, 3x and 3x is 6x, plus 6 minus 13, that's negative 7. That looks pretty good. X minus 1, x plus 2. We haven't canceled anything yet, so we have no restrictions to add yet. We'll have these two in a second. Let's see now. X and 7. 7 is prime, so if it's going to factor, it's going to factor like that. And we're going to need a plus 7 and a minus 1. That looks pretty good. On the bottom we have x minus 1, x plus 2. Perfect. We're going to be able to cancel. Now that I'm writing vertically here, you'll get to see the canceling a little bit better. We have that x can't be equal to positive 1 right there. X plus 7 over x plus 2. Rewrite our first restriction, and then also write down the additional restriction that x can't be equal to negative 2 from this guy right here. Okay, we're doing well. That was part E. We've got F and G left to go. I wonder, I should probably fit F right on here. Let's try that. F's not too big. So this one here, first we're going to do a little common factoring, top and bottom. The top we need to factor out a 2 and an x. And I'm actually going to factor out negative 2x because I don't like this negative sign on my largest degree term. So let's take out negative 2x. We will be left with x squared and then a minus 16. Ooh, that's very nice. That looks like a difference of squares to me. We've already seen one of those. On the bottom, we take out 3. We're left with x squared plus x minus 20. Now that feels like a big number, but that middle number is so small, we're going to end up with 4 and 5 here in just a second. Okay, so negative 2x, x plus 4, x minus 4. On the bottom, 3, x, 4, x, 5. And let's see, this is positive, so we need to have a positive 5 and a negative 4. That way they balance a little bit to the positive. Okay, cool. Now let's do some canceling. I can cancel there, adding the restriction that x can't be equal to 4. And that looks like it. So negative 2x, x plus 4 over 3x plus 5. The restriction is that x can't be equal to 4, and we're going to add one more restriction. Can't be equal to negative 5, because we can see that right there. Now, you might wonder about this 2 and 3. We've got numbers on top and bottom here. You could try to combine those into negative 2/3 or something like that, but it's not really necessary. As long as you have a giant fraction like this, you might as well leave the numbers, the constant part of the coefficient on the top and bottom. Okay, G. This one might be longer. I don't really remember. So, you know what? I'll grab a piece of paper now, just in case. So this one, we have a term minus sort of a giant term here, which is made up of two different expressions being divided. So this is where we will work first, because division is has higher precedence than subtraction does. So we'll work on this part, simplify it, and then see what happens with this other one. So we're basically going to rewrite the first one probably a few times as we work our way through the next part of the expression. First step is to rewrite this as a multiplication instead of a division. Okay, and now I'm going to get rid of that other piece of paper. And once again, I'll just rewrite this. There's a minus. And in order to do some canceling, I'm going to need to factor something probably. Let's see what happens here. When I try to factor this one, I'm going to get x. And if I do 3 and 5, they have a difference of 2, so that's good. 3 and 5 has to be the negative one since we have a leftover of 2 negatives. Okay, cool, that looks good because we're going to get to cancel right here. There, at our restriction, x can't be equal to negative 3. Okay, that's looking pretty good so far. Let me just rewrite what we have. We have x plus 1 over x minus 5, and then x plus 1 over x minus 1, x minus 5. Okay, well that's nice, because once again we have a factor on the bottom that is in common. And so we only have to sort of add in this one over here to make them match. So let's do that. We have x plus 1 over x minus 5. I'm putting everything in brackets now because we're about to multiply by x minus 1 over x minus 1. That's the thing we've now added to this fraction so that it has the same denominator as this one. Now, a very common mistake is going to come right here. This is subtracting this term, this giant term, which means we will be subtracting x plus 1. That is minus x minus 1. So let me write that out. We have x plus 1 times x minus 1 minus x plus 1. I've left it in brackets there so you can see we will end up subtracting that 1. Might wonder about the order here. Doesn't really matter. X minus 5, x minus 1, x minus 1, x minus 5, those are the same thing. Let's simplify this. That looks like a difference of squares there. That's going to be x squared plus 1x minus 1x minus 1. Then we have minus x and minus 1. Oh, I'm sorry, that's off the screen for you. Okay. And then on the bottom we have x minus 5, x minus 1. Nothing to do with that yet till we simplify the top, if it works out at all. Let's see. X squared, I've got a minus x and a minus 2. Okay. And then let's see, that might factor, right? Let's try it out. X and 1. X and 2. Well, if I have a negative 2 and a positive 1, I'll get negative 2 at the end, plus 1x, a minus 2x, that's a minus x, and x squared. That looks great. However, it doesn't really do much for me, does it? Because these aren't the same, nothing is in common here. So the only thing we can do now is simplify is add restrictions. And you know, I just realized I haven't written all my restrictions down along the way. So let me look back. We got rid of a restriction earlier. X could not be equal to negative 3. So let me just write that along the way. You really need this in order for this to be true all the way down. Because these are statement after statement saying these are all equivalent. So x is not equal to negative 3. It's also not equal to positive 1 from here. And it's not equal to positive 5 from there. And I don't think we missed any other restrictions. No, I think we're pretty good. So that is the final simplified version of this. It's actually factored. So if you want technically simplified, it's like it's okay to multiply these out top and bottom. It's not useful to do that, I don't think. But generally speaking, that's allowed. But this is also great. This is kind of all I'm looking for. Okay, so that was the last question. So hopefully that clears up any confusion. And of course, you know you can always ask questions in the comments down below, and I will try to help you out. Okay, thanks very much.